Do you understand what is odd and even functions?
Yeah.
So, okay, already the definition is over there, but can you
Yeah.
explain me or can you give me an example?
Usually, the square functions are even functions
Okay,
because even if you have like a negative square, you still get the positive. You get a positive answer.
correct.
But for example, if you have a negative into square, that is like the -1 is outside, and you're taking the square in brackets.
Hmm.
That case, it's not a even function.
Okay, so okay, for even function, you said if you have x square, it is an even function.
Yeah, like x square is equal to y. So I was saying y is equal to minus of x square.
How is it? How is it an odd function?
Oh no, you still get the same thing for everything. Sorry. Instead, you can take something like maybe a sine function or a cos function. F of
Okay,
x
fine. I'll give you
and f
something.
of minus x.
Yeah, I'll give you something simpler to understand. So an even
Yeah.
function, okay, is something which will be symmetrical about the y-axis, as it is mentioned over here.
Yeah.
Okay, symmetrical about the y-axis. I'm not sure. I'm not sure if this works. Let's see.
It can be symmetric about x also, right? Like,
It will. So okay, if you're looking at an even function, right? In the term y is equal to f of
yeah.
x, it will be symmetrical about the y-axis. If you're looking
Got
at
it.
x equal to f of y, that will be
Yeah.
symmetrical about the x-axis.
Yeah.
Okay, the variable in which the function in this case is in the variable x. Are you there?
Yes, sir.
Yeah. So the variable in the function is x in this case, and hence it is not symmetrical about x, but it is symmetrical about the y-axis. So like you said, any even power of x, okay, like x square, x raised to 4, x raised to 6, okay, in all those cases,
Yeah.
what happens is, let me try to draw it. What happens is you have x square over here. Similarly, you will have x square over here, and this is the symmetrical about the y-axis. Is it clear?
Yes.
Okay, and you can take any power, any even power of x, but that's not limited to it. The even functions are not limited. You can also like you have x square, you can also have another function called x raised to 4, which is an even function.
Yeah.
Okay, I'm just, this is a rough figure, so don't worry about it. Okay, this is x raised to 4. Okay, now both of these are even functions. Even if you take the sum of them, say x raised to 4 plus x square, that will also be an even function.
Yes.
Understood? So even if you add
Yeah.
even functions, you will get an even function. Now,
And if you have an odd power, it won't be.
yeah, so in case of an odd power, what happens? Okay, let's try to look out what happens if it's an odd power. So x cube will look similar on this side. That will not change. But how will x cube look on the other side?
At the lower left quadrant,
Lower left or third quadrant.
third quadrant. Yeah.
So the way it goes above, okay, if it would have been
Yes.
even, it would have been symmetrical on this side. But
Yeah.
after getting its symmetry about the y-axis and again taking its symmetry about the x-axis, what you are getting, that becomes your odd function.
Yeah.
Basically, it is symmetrical about the origin.
Yes.
Okay, symmetrical about the origin. So in which way you are moving away from the origin over here, similar way you will move on the other side of the origin. That's how your odd function is defined. Okay, simpler example is odd powers of x. Okay, x in
Yeah.
itself, y is equal to x. If it is positive, it will be positive. If it is negative, it will be negative. Okay, x cube, x raised to
Yeah.
5. Again over there, if you add two odd functions, you will get an odd function. Okay, so the correct way of remembering them is if f of minus x is equal to f of x, then it's an even function. And if
Yes.
f of minus x is equal to minus f of x, then it is a odd function.
Yeah.
Understand this, that it is not necessary that a function has to be odd or a function has to be even. Function can
Yeah.
be neither as well.
Yeah.
Okay,
Okay.
if I give you
Yeah.
x square plus x cube, this function is neither odd nor even.
Yeah.
Okay, understand this. So if you have a function which is not even, don't conclude that it is odd.
Got it. Check if it's odd.
Yeah, check if it is odd, and yeah, if it is odd, then okay. If it is not, you will know. Okay, so how does it work? So f of x is an even function. Then what happens with the integral aspect? So integration is area under the curve.
Yeah.
Correct. So let's say that you have, let me change the pen. You have y is equal to x square, and you have this particular thing. Now you know that this curve is symmetrical,
Yes.
which means this area will also be equal
Yes.
on both sides of the curve.
Yeah.
Correct? And if you know they are equal, you know you can split them from 0 to a, and you can write 2 times
Yes.
that particular area. Does this make sense?
Yes, it does.
Okay. Now let's look at the other one. In an odd function, this integration is said to be 0. Can you explain why it will be 0?
Because whatever odd part is, I mean, the positive part is there, and equally negative part is going to be there, and so
Yeah. So we
plus
had
minus
in
0.
the last class we had seen that integration value can also be negative,
Yes.
and that does not mean it is wrong. It only means it is below
Negative
the
part.
reference point. It's in the negative direction. So similarly over here, if you're taking this as your limits, this area is considered to be positive and this area is considered to be negative, and therefore your sum becomes 0. Clear?
Yes.
So that's why your integration value becomes 0. Now let's proceed further. Reduction formula. Integration of 0 to pi by 2 sin raised to nx dx is equal to 0 to pi by 2 cos raised to nx dx, n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 dot, dot, till 2 by 3. This is if n is odd. Okay, we don't have the proofs for them, so these are just the formulae for you to keep in mind.
Yep.
Okay, you can try to verify them if you want. Like let's say let's do for the even one, because this n is odd. We can come to n is odd later. Let's do an even one. Sin raised to nx cos raised to nx becomes n minus 1. The same thing follows till you get half, and then you multiply it by pi by 2 as well. Only if n is even. So what is sin square x? What is how do you integrate sin square x?
First you do this thing for sine, and then no, you convert sine square x, right?
Yeah. What do you get?
Trigonometric formula.
1 minus cos 2x by 2.
Yes.
Is that correct?
Yeah, 1 minus cos 2x by 2.
Correct. So that is half minus cos 2x by 2. Half integral becomes x.
Yes.
Half x, sorry. And if you put the limits, you get half pi by 2.
Half pi by 2, yeah.
That I can keep it separately. And
Yes.
you have minus half cos 2x, minus half kept separately. Cos 2x integration becomes sin 2x by 2.
Yes.
That 2 again can take outside. So minus 1 by 4, I'll leave it out. And you have sin 2x with the limit 0 to pi by 2. If you put pi by 2, that becomes sin pi. And if you put 0, it is sin 0. Sin pi minus sin 0. And both the values are 0.
Yep.
So you get 0 as the second term. So you are left with only half into pi by 2.
Pi by 2.
Which is, if in this case you put n as 2, this becomes half.
Yes.
Which is the last term you should have, and that gets multiplied by pi by 2, which means at least you can say that this is working.
Yeah.
Okay. Okay. Similarly, you have the third. Okay.
So that's an odd and an even function.
Yeah, the third one is where you have sin raised to mx into cos raised to nx dx. You have two different powers, and with these two different
both
powers,
m and n are even.
Yeah, that k becomes pi by 2 if both m and n are even. But what if both are not?
Not even.
Yeah, they have not given anything about it.
No.
What happens in that?
Maybe we just need that condition.
Yeah, but if you come across the other thing, they have not given anything.
Yeah,
They have
maybe
not
we
told
won't.
anything.
Yeah,
Okay.
they haven't.
We will look into it further. We will see what we are getting at. Let's proceed further for the moment. Change
Yes,
of order of integration.
yeah,
I believe
changing order.
you were talking about this, I believe.
Yes, sir.
Okay. So change of order of integration changes the limit of integration in a double integration. Okay. So basically you have one constant and you have the other in terms of a variable, the other variable, obviously. So change of order is basically you change the limits of both the integrals.
Yes.
Okay. Such that your inner integral goes out and your outer integral comes inside.
Yeah.
And it's not like you need to do it every time, but sometimes changing the order will help you in the overall integration process. So we'll see
Yes.
how it helps. Let's have a look. Sometimes it is required to split up the region of integration, and the given integral is expressed as the sum of a number of double integrals with changed limits. This method facilitates the evaluation of a double integral. The advantage of this procedure is that the double integral, which is difficult to be evaluated in the existing form, becomes easy for evaluation on changing the order of integration. The computation work can often be reduced by interchanging the order of integration. Let's look at a problem. You have been given 0 to 2, x square to 2 minus x, xy dy dx. In this case, your dy is inside, and obviously your limits are in terms of x, so you understand your y is your inner integral, and the outer integral is x dx. Okay, clear?
Yep.
Given limits, x is equal to 0 and x is equal to 2, y is equal to x square and y is equal to 2 minus x. Y is equal to 2 minus x has been converted into a straight line, x plus y equal to 2. Okay?
Yep. Yes.
Now, what is happening? The point of intersection is 1 comma 1. Now, you have two equations over here for y. Y is equal to x square and x plus y equal to 2. So you can easily draw both of these equations on your graph paper. Y is equal to x square is an upright parabola opening at the top. X plus y is equal to 2 will be a line which has a negative slope, meaning the angle made with the positive direction of x-axis will be more than 90 degrees. Okay. In this case, because it's minus 1, you can say it is 135 degrees. So basically, this is 90, and this additional angle will be 45. So 135.
Yeah.
Clear that?
Yes, sir.
Now we look at the points of intersection. For the points of intersection, what you can do is you can simply substitute this 2 minus x over here in place of y. You'll get a quadratic in x. Correct?
Yeah.
So that quadratic is x square plus x minus 2 is equal to 0.
Minus 2.
Yeah. Because your constant is negative, which means you will have one positive and one negative solution. So plus 2 and minus 1, and it will reverse. So you'll get minus 2 and plus 1. So minus 2 will be the point of intersection over here. X is equal to minus 2.
Yes.
Okay. If you put x is equal to minus 2, you will get y is equal to 4. So that is your one point of intersection, minus 2 comma 4. And if you put x equal to 1, you will get y is equal to 1.
You get y equal to 1.
Which will be your this point of intersection. Correct?
Yes.
Now, the way the integration is done, okay. Now this is the function that you're integrating. Okay. What does this function represent? This function represents the height of the bar.
Height.
Okay. It's in along the z-axis. So coming out of the paper is what you are thinking. Xy is that the surface which will cut that particular height at a particular height. So we have to now check whether this integration, the order of integration, works. Now you're doing x squared to 2 minus x, which means you are going in this direction. Can I draw it over here? Your bar, it will be in this direction. Correct? X square on this curve and 2 minus x on this curve.
Yeah.
Not curve, the line. So that is how your bar will be. But what happens, you see, when you're integrating from here to here, till this particular point, 1 comma 1, okay, it is correct. Till this point, it is correct. But below this, it is not correct.
Yeah.
Okay, this limit will actually be x square to x square only, below 1 comma 1 point. Meaning, doing this particular integration is actually going to be difficult.
Yeah.
So now what happens is, now changing the integration means you're going from bottom point to upper point. You are going to change the bar like this.
Yeah.
Okay. In this case, you are over here, your x limits were 0 to 2. Sorry.
Y limits were 0 to 2.
No, these are not y limits. Oh, yeah.
Those are x limits.
Just let me complete.
X limits.
Yeah, 0 to 2 were x limits. That's correct. One second. Yeah, 0 to 2 were x limits. X equal to 0. X equal to 0 is your y-axis. X equal to 2 is your this line. Okay. So you have to find this particular area. Is this clear?
Yes, sir.
Okay, not the entire thing. Even though you have this particular line, x equal to 2, your curve actually does not go beyond this. That's what I understand from this figure. Let me. X equal to 0, x equal to 2. But x equal to 2 does not come into the picture at all, right? With the intersection. You can only enclose it on one side. Okay, let's see how they have proceeded. So they have changed the integration limits. Oh, okay.
We were supposed to use the new limits.
One second. What have they done? Changing the order. So y is equal to 0. That is your x-axis.
Yeah.
Till y is equal to 1. That is basically till this particular point. Okay.
Yeah.
And then from this particular point to this, that is your upper triangle. Okay. What has happened? Your limits of x, okay, you have changed instead of looking at x equal to 0 to x equal to 2, okay, you are now going from y is equal to 0
Y
to y is equal to 1.
1.
It is that your point of intersection.
Yeah.
Over here, you see your x is actually changing from 0 to root y.
Yeah.
But on the other side, you're starting from x equal to 0 and it's going from x equal to 2 minus y, which is your straight line.
Yeah.
And then you are doing the integration. Let me just have a look. So y is common, x dx becomes x square by 2. You substitute, x equal to root y becomes y minus 0, so y by 2. Y square
Y
by
square
2,
by 2.
half outside becomes y cube by 3. 1 by 6 y cube. 1 by 6 y cube becomes 1 by 6. So the first term is 1 by 6.
Okay.
The second term is y x square by 2. Oh, this will be difficult because you have x square by 2. So that becomes 2 minus y the whole square by 2.
So can't you take the 2 out?
Which 2? This one?
The by 2, yeah.
Yeah, that will go out. That's fine. Half will come out. But
Yeah.
then you have
Then you
2 minus y the whole square, which you will have to expand.
yeah.
Multiply each term by y. And after multiplying each term by
Y
y,
cube
then
minus
integrate.
y cube minus 4y plus 2y.
Y cube minus 4y square plus
Y
4y.
square, yeah.
Plus
Plus
4y. That's correct.
Plus 4y.
Yeah. And then you have to integrate them. And after integrating, you have to
Yeah.
substitute the limits as well. So basically, they have skipped a lot of steps over here.
Yeah.
You can't come for this answer.
To 3 by 8.
Yeah, you can't come it in one step. Okay.
Yeah.
I would like you to verify this particular answer.
Yes, sir.
13.1. I'll just make a note of it.
So the y cube thing and all, I can do it with linear this thing, right? Split it up and
Sorry?
the y cube minus 4y square.
Yeah, it will be
plus
separate
4y,
integrals.
yeah, linear.
Yes, yes. Okay, you have to solve this particular question. Shall we proceed further?
Yes, sir.
Okay, evaluate by changing the order 0 to 1, x to root of 2 minus x square, x upon root of x square plus y square dy dx. Okay, again, you can ignore this particular part. You will be focusing on only the limits. If you look at the limits, you have y is equal to x, which is a straight line, and you have y is equal to root of 2 minus x square, which means x square plus y square is equal to 2, being a circle. And since your integration is from x equal to 0 to x equal to 1, these are the two lines you'll be focusing on, and your integration is from x to 2 root of 2 minus x square, which means y is equal to x. You are looking at this particular example, okay, the upper cross section.
Yeah.
Because you're going from y is equal to x, which is your this line, and you're going up to y is equal to root of 2 minus x square. I did a mistake in the other part, I believe. One second. In this particular question, I had y is equal to x square to y is equal to 2 minus x. Actually, it meant this particular bar. Okay. Over here, if you would have solved, okay, using directly rather than changing the order, what you would have to understand is you would have got this negative area as well. Not sure whether you will call it
Yeah.
negative. You will have to call it negative area, because when you're going from x square to 2 minus x, this is positive direction going upwards from
Yes,
this
sir.
to this, whereas over here it would have been negative going in
Yeah.
the negative direction downwards from x square being at the top and 2 minus x being at the bottom. Are you understanding?
Yes, sir.
That's why changing of order was very important, or else you can just simply do the same integration. Instead of 0 to 2, if you do 0 to 1, can you check what would be the answer? Please make a note of this.
For what, sir?
Same question, okay?
Yeah.
You are already doing this particular aspect to check your answer, correct?
Yes, sir.
But I wanted to do the same question without changing the order.
Already.
Without changing the order, just make this 0 to 1,
0 to
1,
okay.
and solve the question without changing
Okay.
the limit, changing the order directly as it is.
Got
Okay. Let me know
Yeah.
what you.
So
what you-
basically, you want me to do the y part first and then the x part, right?
Yes, yes. But instead of 0 to 2, you'll have 0 to 1.
1. Yeah.
Okay. Coming back to this particular question, you are clear which area we are focusing on,
Yes.
looking at the limits. Again, over here, I don't see the need to change the limits, considering what is given is perfectly fine. 0 to 1. 1 second. Y is equal to 0. Y is equal to 1. Oh, okay. Huh? Sorry, x equal to 0 and x equal to 1. Okay, these two are your limits, and you are doing this particular thing. Okay, fine. Okay, again, over here, I don't see the need for changing the order, but you have been asked to change the order in this particular question. So, how does it actually help you? Let's see. You're clear with what area we are focusing on?
Yes, sir.
Okay, not the lower part, only the upper part.
Upper part.
Basically, you can call this to be a sector of the circle.
Yes, sir.
So, for this particular sector, now the x values were 0 to 1. So, you are now changing this particular sector. Your y values, now you are going to split the sections again. You will split it at this particular point 1 comma 1, where below this line, okay, this is your line, below this line your what do you say, the limits of x will be from y axis to the line, okay.
Yes, sir.
Whereas above the line it will be from y axis to the edge of the circle. Am I clear? Not clear?
Yes, sir.
So you have y is equal to 0 to y is equal to 1. Y is equal to 0 is your x-axis. Y is equal to 1 is basically this particular line that I have drawn.
Yes.
And your x limits will be x equal to 0 to x equal to y, which is this particular 45 degrees inclined line. And the rest of the integration terms will remain as it is. And the upper part, you will have 1, y is equal to 1, 2, y is equal to root 2, which is the maximum point the circle is cutting the y-axis.
Yeah.
And then your x limits will be x equal to 0 to the limit of x defined in terms of y, which will be root of 2 minus y square. And you will now integrate these two integrals separately. So what I'm seeing in both these problems is you are trying to split the integral, or the order change has made you look at the problem in two different steps rather than in a single step.
Yeah.
Okay, every time you are coming to find an area, you are trying to change the order, which will help you split the question and focus on getting the answers separately, making it probably an easier calculation. But that is something that you will solve and you will let me know.
Yes.
Okay, so when you're doing the integral, you are doing u is equal to x square plus y square. Okay, for you, y is a constant while you're doing the inner integral over here. Oh, this is why it is helping. Okay, understand this. You have root of x square plus y square.
Yeah.
And you have the inner integral dy.
Yes.
Which means you have to integrate with y as a variable, x being a constant.
Yeah.
And
yes.
This is going to make it difficult for you to integrate because you do not have anything with regards to y square in the top for solving it.
Yeah.
Or it will be more complicated, more importantly.
Yeah.
Considering the formulas you have in integration. But when you do it while reversing, what happens is your y has become a constant and x has become the variable. And if you take this as u, as they have done over here, the numerator x goes away in the derivative of the substitution. So this integral turns out to be simply half 1 by root u du, where this can be written as u raised to minus half. U raised to minus half integration becomes u raised to half by half, which gets cancelled with this, and that will be your simple root of x square plus y square. Is that clear?
Yes, sir.
The change of integration actually helped in
Simplifying
making the
the
calculation simpler in this particular case.
Yeah.
And then
Yes,
you simply do, okay, this is the simple integration. You substitute the values. You put x equal to, okay. So you have just substituted this and you have substituted the values x equal to y and x equal to 0. This becomes, if you put x equal to y, this becomes root of 2y square. That is root 2y minus y. That is root 2 minus 1y. Root 2 minus 1 taken common. Over here, you will substitute 2 minus y square, which becomes root 2. And if you put 0, 1 second. Okay, root 2 minus y. Okay, now this is, okay, again they have jumped the step over here. Okay, they have come directly to the answer, but that is not the right way.
Yes.
Okay, this should have been elaborated. So again, I would recommend you to do this one as well and check whether you're getting the right answer or are you getting stuck at a particular step. Is that clear?
Yes, sir. Yep.
Okay, today's class is going to be much lengthier because of the missed steps. Let's look at the next problem. Order of integration, evaluate 0 to a integral root ax to a y square upon y raised to 4 minus a square x square dy dx. Again, in this case, you have to do integration with respect to y. Which can be simplified y square minus ax into y square plus ax. Does it help? Oh, yes. Y square in the top. I think you can. Okay, let's look at the. So you have x equal to 0 to x equal to a, which becomes your y-axis and a line parallel to the y-axis. And then you have y is equal to a and y is equal to root ax, which is y is equal to is this. Y is equal to root ax. You can simplify this. You get x equal to y square upon a. This is wrong, okay? It's not x equal to y square. It is x equal to y square upon a. Y square equal to ax is a correct interpretation. Is that clear?
Yes, sir.
And then you can find out the integration points. This is y is equal to a. You can substitute y is equal to a, and you will get the value of x as a. So a comma a is correct. You have to find 0 to x equal to a, y is equal to a to y is equal to root ax. Sorry, root ax to a. Okay. So this is your shaded region is the area that you're targeting. And now you are changing the order of integral. So rather than having the order of integral like this, you will have the order of integral like this. And that will change. Your x value is going to change from x equal to 0 to x equal to a. Oh, sorry. The y integral changes from y is equal to 0 to y is equal to a. And your x values becomes x equal to 0 to x equal to, that will be y square by, it's not 2, okay, it's a. Is this clear?
Okay.
This cannot be 2.
Yeah.
It has to be y square by a. And then you substitute. Now in this particular case, because y is a constant, this becomes a variable in x. So you have constant upon constant square minus square x square. Because of this a and the constant, so y square by a comes out, and then you have a sine inverse of ax upon y square. And then you substitute the values. Y square by 2, it should be y square by a, not y square by 2. If you put y square by a, it will become 1. Okay, this becomes sine inverse 1 when you put y square by a. And when you put 0, it becomes 0. Sine inverse 1 minus sine inverse 0. Sine inverse 1 is pi by 2. Sine inverse 0 is 0. Pi by 2a comes outside. Integral of y square is y cube by 3. You substitute 0 to a, and that becomes a cube by 3. A square 6. And that is correct. Pi a square by 6. And that only happened because of the change in order, or else you could not have applied a direct formula for sine inverse. Is that clear?
Yes.
Okay, you have a few more exercise problems on page 15. Let's proceed further. Jacobians. Let u is equal to u of x comma y and v is equal to v of x comma y are continuous functions of two independent variables x and y having continuous partial derivatives. Then Jacobian of uv with respect to x and y is denoted by j, or partial derivative of u comma v with respect to partial derivative x comma y, and is defined as the determinant. Okay, so you have two separate functions u and v, and both of them have two independent variables x and y. Okay, because you are having
Yeah.
two independent variables, okay, the derivatives are not proper derivatives, but they are partial derivatives. Does that make sense?
Yeah. Yeah. Partial derivatives was the first this time.
Correct. And when you have partial derivatives, in that case, you will have, because you are looking at two different functions, you will have two
Yeah.
partial derivatives for each of those functions.
Yes.
Okay, and therefore it is represented in this particular determinant. And depending on the number of variables and the number of functions and the number of independent variables, this can be extended beyond multiple functions and variables as well. Is this clear?
Yeah.
Let's proceed further. What are the properties? So J1 is this and J2 is this. J2 is basically the reverse, as you can look at it. Why is it the reverse? Because if u and v, okay, I'm not sure if you have come across this. You know, when you, for the graph paper, when you have the y is equal to f of x function,
Yeah.
you can also represent x is equal to f of y for the same function.
Okay.
Okay, the function does not remain the same. Like if I have y is equal to x square, then I'll write x is equal to
Oh
root
yeah.
of y.
Yeah.
Okay, so it's not, if y is equal to f of x will also be g of y in that case.
Yeah.
Okay, similarly, if u and v are two functions with two independent variables x and y, similarly you can have x and y as two functions with independent variables u and v.
Yeah.
And in that case, you will have a Jacobian of this and a Jacobian of this, such that in this particular case, because you have it this way, the multiplication of the derivatives will be equal to 1. similar to
Yeah.
inverse of a matrix, similar to that.
Yeah.
And in this case, if the determinant value is not 0, then you can say one determinant is equal to 1 by the other determinant. Is that clear?
Yes, sir.
And that is very simple because you have these Jacobians as the determinant values, and you can just do this multiplied by this, and you'll have this multiplied by this over here. You know how to multiply matrices, right?
Yeah.
This is actually determinants, but I think it's the same thing. Okay.
Multiplication of determinants.
It actually should be a matrix according to me, not a determinant. I'm not sure determinants are multiplied this way. Should have been a matrix according to me. Just remind me this particular part.
Matrix?
I'll
Yes, sir.
check that once more. I think these should have
Yes,
been
sir.
matrices, and matrices when they multiply, you'll get it equal to 1. Okay?
Yeah.
Okay. Do you understand why this is 0? So you understand this is 1. Let's look at the first term. Okay. In the first term,
Yeah.
delta x gets cancelled. Delta y
Yeah.
gets cancelled.
Yeah.
Actually,
Everything gets cancelled. It becomes 1 plus 1.
yeah, it should be 1 plus 1. And over here, everything doesn't get cancelled. You have delta u by delta v plus delta u by delta
U
v.
by delta.
Over here, again, this gets cancelled. Delta v by delta u plus delta v by delta u. And over here, delta v by delta v plus delta v by delta v. So I'm not sure why this is coming as 1. Okay, I'll have to get back to you with this particular thing. This does not seem to be
Yes.
correctly written. I'll get back to that. U and v are functions of Rs, and Rs are functions of xy. Then this is a partial derivative thing, kind of a chain rule.
Yeah.
Okay.
Yes.
If x is equal to x u v y is equal to are 1 to 1 and onto functions of u and v with Jacobian not equal to 0, then the integral, double integral f of xy dx dy is double integral f of with the Jacobian du dv. So basically, if you have xy over here, okay, the function of xy,
Yeah.
and because we know x and y are already functions of u and v, you can
Yes.
improve or change the function, replace the function with the Jacobian and du dv, the new variables.
Yes.
U is x square y, v is 5x plus sine y. You will differentiate delta u by delta x. So y is constant, x square is 2x, 2xy. Delta u delta y is x square. Delta v delta x is, this is a constant 0, so 5. Delta u delta y, this becomes 0 and this becomes cos y. And then you just simply cross multiply, opening up the determinant 2xy cos y minus 5xy. And that's what is a determinant.
Yeah.
So over here, what has happened?
So basically, what they're trying to tell us is you take the derivative of those terms and you put it as a determinant, right?
Yes. That's why this actually is not making
This part.
sense.
Yeah.
Because the determinant do not get multiplied that way. This opening up the determinant is fine. This is understandable. Okay, consider the transformation from Cartesian to polar coordinates. Do you know polar coordinates?
Not very well.
Okay, so on the graph
This.
paper, right? On the graph paper,
Yeah.
you have your x and y coordinates,
Yes.
correct? So xy, you define that particular point on the xy axis. Okay, x comma y.
Yes.
Now, when that point is connected to the origin, okay,
Yeah.
the distance is called r. Okay, that is the length or
Yeah.
the distance from the origin. That segment which is drawn, the length of that segment is r, and the angle it makes with the positive direction of the x-axis, that is theta.
Yeah.
Okay, so the point xy, if I have to write it in polar coordinates, it is written as r
Yeah.
theta. Okay, now what is r? R is simply root of x square plus y square using Pythagoras theorem.
Yes. Okay. Yeah.
Okay, r is root of x square plus y square. What is theta? Theta will be tan inverse y by x.
Yeah.
Okay, that is how, if you know the Cartesian coordinates, you can replace it to polar coordinates. Now you have to convert it the reverse way. I know r, I know theta, so I can say r cos theta is x and r sin theta is y.
Yeah. Yes.
Is this clear?
Yeah.
So you have both x and y in terms of r and theta.
Yeah.
So they have just simply substituted that and taken the derivatives, the partial derivatives.
Yeah.
And r is, what is this? Okay, so you when you multiply, you get r cos square theta minus r sin square theta, which becomes r bracket cos square theta plus sin square theta. Did you understand?
No, so I didn't hear what you said.
Okay, this is the determinant. So when you cross multiply cos theta into r
Yeah.
cos theta is r cos square theta,
Yes.
and then you do a
Minus
minus
r sin
of
square theta.
minus r into sine square theta, which becomes plus r sine square theta.
Plus r. Yeah.
R taken common, you have cos square theta plus sine square theta, which is equal to 1.
Yeah. Yes.
So you finally get r, the Jacobian value, which is r is expected to be greater than 0.
Yeah.
Unless you are standing at the origin, and therefore this particular aspect is same as f r cos theta r sin theta r dr d theta. So what they have done is they have modified, or they have replaced f of xy dx dy into Cartesian coordinates, where the Jacobian value is actually r. So they have put an additional r over here. Is this clear?
Yes, sir.
Example 3, let's look at it. Consider the transformation from Cartesian coordinate cylindrical coordinate system. Now in the cylindrical coordinate system you have z as the third dimension, but that is not going to affect your, what do you call, the dimension. The third dimension will remain as it is, whereas your r and theta are now represented as rho and phi.
Yeah.
Okay, again rho is your basically going to be the radius, okay, and it can go from 0 to infinity, whereas phi is your angle on your xy plane, and it can go from 0 to 2 pi, 0 to 360.
Yeah.
But you are mentioning the angles in radians,
Yes.
and therefore you have c1 c2 c, okay, represents a cylinder. C2, if you are giving only a some constant, represents a half plane. C3, plane parallel to xy plane. C1 c2 represents a line. C1 and c3 represents a circle. C2 and c3 represents a half line, a ray. Okay, so they are just giving if what happens if one of them is fixed. So if your radius becomes fixed only, with the other two extending in any dimensions, so let's say that the radius is constant,
Yes,
rho is a constant, and your phi can vary from 0 to 2 pi, then it becomes a circle. And if z can also go in any length, then it becomes a proper cylinder.
Yes.
If you look at the angle phi, now if you do not have any particular rho which can keep on changing, that's a difficult one to actually explain. A half plane, this is simple. Z is equal to c3, which means you have a plane parallel to the xy axis, which gives you a constant height z.
Yes, sir.
Phi is equal to constant represents a, oh okay, phi is equal to constant. Phi is actually an angle,
Yes.
and if your angle is a
Phi,
constant,
yes.
which means you are going to get a plane in that angle.
Yeah. Yes.
Okay, irrespective of where your z is, irrespective of what your r is. So first three are clear. Now if you are having two conditions constants, so you have a particular rho and a particular angle, then it becomes a line, correct?
Yes, sir.
It should actually be a half line or a ray, but okay, I think this should also be a half line, similar to the last condition which is mentioned over here. If you have a particular rho value and a particular z value, that is the height, then it represents a circle. How does it represent a circle? Z is a constant, rho is a constant. Okay, not sure of this one. The last one is a half line, very similar to this particular condition, but we shall have to get back to that. Let's move on to this particular thing. This is a Jacobian again. You have three particular variables x, y, z, and you have three independent variables rho, phi, and z mentioned over here. And we already know how x, y, and z can be represented in the other cylindrical coordinate system. These are the three. Hello?
Yes, sir.
Oh, had you left? What happened?
Yeah, kind of. Oh no, it got disconnected, so I rejoined.
Okay, fine. So are you clear about, like I was talking about the Jacobian. When did you actually miss out?
So when you were talking about how the plane is at that angle.
The half plane?
Yeah.
Okay, fine. So these are basically aspects which represent if one of them is a constant. I'm not sure it's going to be much helpful because you'll have to imagine a lot of things over here. Let's proceed
Yeah.
To the Jacobian part. In the Jacobian, we already know that the three x, y, z, okay, are represented in the cylindrical coordinate system as per this. X is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. So then you can take the partial derivatives and you can get this particular Jacobian. And if you expand this at the end, you are going to get rho, very similar to what you had in the previous one in the polar coordinates.
Yeah.
So in
Yes,
this
sir.
case, this becomes equal to this particular this.
Yeah.
Now you have the Cartesian coordinate system. In the Cartesian coordinate system, you have the three particular variables. One is r, which is a radius, and because it's a solid sphere, your radius can be anywhere between 0 to the radius of the sphere. Okay.
Yeah.
This angle phi is the angle between the positive x-axis and the line above. So when you look at a 3D model, you will have two angles to reach a particular point. The first angle is the angle between the positive x-axis and the line above. When you say the line above, it is going to be, I have to draw a figure to help you explain this particular aspect. Oh, there is a figure. Oh, sorry. Okay, so this is your point P. Okay, the
Yes,
distance from the origin is directly r. That becomes your first variable.
yes, sir.
Now, to get to this particular point, you need an angle from the x-axis on the xy plane, which will be its projection on the xy plane. Now, this point which you see at the bottom of P, okay,
Yeah.
this is, you can call the projection of P on xy plane.
Yeah.
This projection makes an angle with the origin to the positive
Yeah.
x-axis. That angle
Yes.
is called phi.
Okay.
This angle phi can be anywhere between 0 to 2 pi.
Yeah.
Okay, that will define where P lies. Okay,
Yes.
like in the xy plane, you know that we have 4 quadrants: first, second, third, fourth. Correct.
Yeah.
But if you're looking at 3D, you can have you won't call it a quadrant. It's basically kind of a sector. I'm not.
8 sectors.
Yeah, 8 sectors. That's correct. So I'm not sure if sector is the right word, but you understood what I mean to say.
Yeah.
So
Basically grids.
grids. Grid is also, I would not say the right word, but you understood what I'm saying. And basically, your
Yeah.
0 to 2 pi angle will decide which sector is that point lying in. It can be
Yeah.
like the angle will not. This angle is not going to determine whether it's above the xy plane or below the xy plane, but it will
Yeah.
tell you it is actually in which of those two, like which two sectors can it lie in.
Yeah.
Out of those 8. Okay, that is the
Yeah.
angle phi. Whereas theta is with the positive z axis, and this will tell you if it is less than 90, then you will know it is above the xy plane, and if it is greater than 90, you know it is below the xy plane.
Okay. Yeah.
And for your the 3 original Cartesian coordinates x, y, z, they can be uh, written with these 3 variables r, theta, and phi as per this. And
Yeah.
you can even check the geometry over here. Let's look at it. This is r, and your angle is theta over here. So r and theta, if you look at closely, this is r cos theta. So r cos theta becomes your z, which is mentioned over here, because this angle is theta. Okay.
Yeah.
Now this line, the projection of that line is actually r sine theta.
Yes, sir.
The projection of this line is r sine theta, and from this projection you can get the x and y coordinates. So r
Yeah.
sine theta cos phi becomes your x variable x, and r sine theta sine phi becomes your variable y. Is that clear?
Yes, sir.
For the angle theta, you only have 0 to pi. You don't have to go 0 to 2 pi. I hope that is also clear. 0 to 90 is above the xy
Yes,
plane,
sir.
90 to 180 is below the xy plane.
Yeah.
Again, this gives you what exactly each of these. If your r is a constant, it represents a sphere with center at the origin and radius c1. If you have phi as a constant, phi is an angle. Okay, if this angle is a constant, it represents a half plane. If theta is equal to a constant, represents a cone with semi-vertical angle c3. If r is a constant and phi is c2, represents a semicircle. Circle represents a half line. Now again, this is slightly difficult for me to explain right now. So let's proceed further with the Jacobian part. Over here, if you simplify this particular determinant, okay, again, these are the partial derivatives of this, correct? X equal to r sine theta
Yes.
cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta, and you find the partial derivatives, you substitute in them, and then you take the determinant. You will finally solve this and get r square sine theta. And when you try to do the integration, okay, they have not written the final form. Okay, the final form will be as you see this final form.
Yes, sir.
Okay, so x, y, z, dx, dy, z, dz, it becomes, instead of rho cos phi, rho sin phi, and z, it will be r sin phi, sorry, r sin theta sin phi, r sin theta cos phi, r sin theta sin phi, and r cos theta. And instead of rho over here, you'll have r square sin theta. the
Yes.
Jacobian value for spherical coordinate system. Siddharth, are you there?
Yes, sir. Yes, sir.
Okay. So now let's proceed over here. What are the examples? U is equal to x plus 3y square minus z cube. V is equal to, so you have been given x, sorry, u, v, and w, three functions in terms of three variables x, y, and z,